Hello everyone, in today's topic, we are going to discuss angles of elevation and depression. What are angles of elevation? It is the angle between the horizontal line through the eye of an observer and the line of sight of an object when the object is above the horizontal line. So this is the illustration wherein the angle of elevation is being described. So we have the line of sight and the horizontal line, which makes up the angle of elevation. So your keywords in here, if someone is looking up, then it makes an angle of elevation. Now let us have the angles of depression. So it is the angle between the horizontal line through the eye of an observer and the line of sight of an object when the object is below the horizontal line. So your keywords here is below the horizontal line. Supposing we have a man looking down, so the angle that makes up the horizontal line and the line of sight is the angle of depression. So keywords for this one, if someone is looking down, it makes an angle of depression. So let us have some situations regarding angles of elevation and depression. So in here, when a pilot is looking down, it makes up the angle of depression, and when a man is looking up to an airplane, it is the angle of elevation. And here is also another scenario of the angle of elevation and angle of depression. And this one too illustrates angle of depression and angle of elevation. So take note that the angle of elevation and the angle of depression is always measured from the horizontal line, and that the angle of elevation and angle of depression are always equal to each other. Why? Because when two parallel lines are cut by a transversal line, the alternate interior angles are always equal to each other. So when two parallel lines are cut by a transversal line, their alternate interior angles are congruent. There is a common error in angle of depression. So sometimes we draw like this, but it is not correct. It should be like this. It is always based on the horizontal line. Before we can solve any situations involving angles of elevation and depression, we are going to represent them, or we are going to draw. So in this example, a ship is 120 meters from the lighthouse, and from the ship, the angle of elevation of the top of the lighthouse is 30 degrees. So let us draw a diagram to represent the above situation. So in here, this is the ship. From the lighthouse, it is 120 meters away. And then if we connect all the sides, we can create a right triangle. So the angle of elevation from the ship to the lighthouse is 30 degrees. And on the other way around, this is the illustration. So we have the 30 degrees angle of elevation. So from this one, we can deduce that it makes up a right triangle. So in here, we can apply the concept on trigonometry to solve for the unknown later on. So let us represent example number 2. So from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. The tower is 45 feet in height. So to illustrate this one, we have the horizontal line and we have the angle of depression, which is equal to 40 degrees. And we have the height of the tower, which is equal to 45 feet. And because we have the angle of depression already, we have the angle of elevation, which is equal to 40 degrees. Once we already illustrate the problem, we are now ready to solve. So in order to solve for the unknowns, we are going to use trigonometry. And we have the SO, the KA, and the TOA. So we have sine theta is equal to opposite over hypotenuse. cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. So in here, if the theta or the angle is here, this is your opposite side, and this is your adjacent side. Adjacent means that it is the side near to your angle, and always the side opposite your right angle is your hypotenuse. But if your theta is here, this is your opposite side, and this is your adjacent side, the side close to your theta. And always the side opposite your right angle will be your hypotenuse. So now we are ready to solve. So let us have example number 1, which is our example a while back. But now we are going to solve it. A ship is 120 meters from the lighthouse, and from the ship, the angle of elevation of the top of the lighthouse is 30 degrees. What is the height of the lighthouse? So in here, illustrating it, we are going to solve for the height of the lighthouse. In doing this so this is your x, which is the height of the lighthouse, and we are going to use tangent theta. Why? Because if this is your angle, 30 degrees, this is your opposite, and this is your adjacent. So substituting all the values, we get tangent 30 degrees is equal to x over 100 meters. And then we are going to cross multiply. So we get tangent 30 degrees times 120 meters is equal to x. Then using your calculator, you just need to encode it or type it in your calculator. So it will become x is equal to 40 times square root of 3 meters, or simply pressing your SD, it will become 69.28 meters. So the height of the lighthouse is equal to 69.28 meters. So let us have example number 2, which we have a while back. So in here, please do note that if we are going to round it to the nearest tenth of a foot, we need to have 1 decimal point. So this is the illustration that we have a while ago. So we have to solve for x. And how to solve for x? So now let us solve for x. So if this is your theta, which is equal to 40 degrees, this is your opposite side, and this is your adjacent side. So x is equal to the distance of the friend from the tower. In order to do so, we are going to use tangent theta, which is equal to opposite over adjacent. Then substituting all the values, we get tangent 40 degrees is equal to 45 feet over x. Then we are going to cross multiply. We get tangent 40 degrees times x is equal to 45 feet. Now we are going to divide both sides by tangent 40 degrees. Then we are going to cancel. So x is equal to 45 feet over tangent 40 degrees. Since we are looking for the distance rounded to 1 decimal point, we get x is equal to 53.6 feet. So let us have another one. So find the shadow cast by a 10-foot lamp post when the angle of elevation of the sun is 58 degrees. Find the length to the nearest tenth of a foot. So in here, we have the x. So we need to solve for x. First, we need to decide what function do we need to use. So in here, we are going to use tangent. So tangent 58 degrees is equal to 10 feet over x. So we get x is equal to 10 feet over tangent 58 degrees. So the answer is 6.2 feet. And that is the solution for the example number 3. Now, this is the other one. So solve the following. This is your exercise. So what is x? Okay, so in here we are going to use sine function. So sine 58 degrees is equal to 10 feet over x. So we get x is equal to 10 feet over sine 58 degrees. So x is equal to 11.8 feet. So that is the solution for your exercise. Now let us have. And before we end up, this is your homework for today. You can send me via line or via the stream in the Google Classroom. So that's it for now. Please click subscribe and thank you for watching. See you again next time. Bye!